Now, here now for this circuit, the voltage to the V total is 12 volts, and we have 3 resistors. One is 11, the second one is 7, and the third one is 20. You need now to find the R equivalent. The first step, the R equivalent here, to find it, as I told you. Now, since they are not connected in the same wire, since they are connected and like, how would you remember, like the rectangular shape have two parallel sides. This is here, they are parallel to each other. Since they are the three resistance are parallel to each other, we call this type of them are connected in parallel circuits. So I am talking here at parallel. So since they are parallel now, we have to remember that 1 over R equivalent will be 1 over R1 plus 1 over R2 plus 1 over R3. Why I stopped here? Because I have only 3 resistance. So in order to find the R equivalent, 1 over R equivalent, the reciprocal of the equivalent will be the summation of the reciprocal of each one. Let's continue now. So 1 over R1, which is 11, plus 1 over 7, plus 1 over 20. R1 is 11, R2 is 7, and R3 is 20. Then you can, we will add them here as 1 over 11 plus 1 over 7 plus 1 over 20. When you add them, you get the answer as 437 over 1540. Now this answer, you get it as 1 over R equivalent is 437 over 1540. If I want now R equivalent, I will write the reciprocal of this number. You will get that the R equivalent here is 3.52. So the R equivalent here will be 3.52 ohm. This is here how to find the R equivalent since they are connected in parallel. Now, why we need to find the equivalent resistance in order to simplify my circuit and help me to find the current that's passing through the circuit. So after you find now the R equivalent, you get that the V total here is 12 volts and the R equivalent is 3.52 ohm. If you have now the volt, the total volt, and if you have the total resistance, you can find the total current. So that's why I simplified them. I simplified them in order to find the I total. So from Ohm's law now, we know that V times, or let's remember, it's like V over R is I. So the I total will be the V total over R total. So the V is 12 and the R total is 3.52. So you will get that the answer here is 3.4 ampere. So the current that's passing through any resistance here will be through, the current that's passing through the circuit here is 3.4 ampere. So here the I total is 3.4 ampere. Now, what about the voltage total or the V total? It's 12 volts. And as I told you now, in the series and the parallel circuit, or in the series, we called it voltage distributor, and on the parallel, we call it current distributor. So since that's me, I told you it is current distributor. So the current here will be distributed to I1, I2, and I3, but the voltage will be the same. So since the voltage here is 12 volts, so that's mean the voltage at the first resistance is 12, at the second resistance is also 12, and the third one will be also 12. It is parallel. Parallel is current distributor. So only the current will be distributed into the resistance, but the voltage will be the same. Like if you have if you bring, a voltmeter here, you will find it's 12. If you put the same voltmeter at this resistance, you will find it's 12. If you put it at this resistance, you will find it's 12, and so on. So you need to, here, if you need to measure the resistance in any, or the voltage in a resistance, you will find they are 12 as the same voltage for the circuit. Now let's talk about the current. The current here will be distributed. Like here, if you have it like, this is the voltage, it will be distributed here, here, and here. After they distributed, they are connecting now at this point with a 3 current, and they are come back as a 3.52. So I have the current here as a 3.4. I have the current here as 3.4 ampere. This 3.4, it comes through the circuit. It will be distributed here into R1, R2, and R3. So when I asked you now, what is the current at R1? I mean I1. How did you find I1? And how did you find I2? And how did you find I3? How did you find I1? By which law? Yes, grade 11.
V over R.
Exactly, which is by Ohm's law. So by V total over R. Or we can say like by V1, since I'm talking about I1. V1 over R1. Now where's V1? It's a 12.
12 over 11.
And R1, it's 11.
11.
So 12 over 11, it is 1.09 or 1.1. So the current that's passing through the first resistor. So just 1 second, please. Here the answer is 1.09 or 1.1. So the I1 here will be 1.1 ampere. Now let's talk about I2 now. I2, I mean like the current on the second resistor. So it will be V2 over R2. Where is V2? 12
over 7.
Where's R2? It is 7. So
7.
the I2 here will be 12 over 7, which is 1.71. So I2 will be 1.71. Now let's talk about I3 now. I3, it's mean V3 over R3. V3, as you know, it's a 12. R3 is 20. So if you divide now 12 over 20, you get it as 0.6 ampere. So the current here through the third resistance will be 0.6. Now let's check if my answer is correct or not. I told you that in the parallel, you have a voltage distributor. So that's mean the voltage will be distributed in the three resistance. So if you add I1 plus I2 plus I3, you must get I total. I1 is 1.1, I2 is 1.71, and I3 is 0.6. Let's add them. 1.1 plus 1.71 plus 0.6, you will get the answer as a 3.41, which is approximately 3.4. So in parallel circuit, as I told you, we have it as voltage, current distributor. The current are different from the resistance, but the voltage will be the same. Is it clear?
Yes, teacher.
Yes, teacher.
Now, let's talk about now, we will start now with a new one, which we have a combination of parallel and series at the same time. Look at the series here, this circuit here. For this circuit, we have this series, this resistance, and this resistance are connected in parallel or in series. How they are connected?
Serious?
Series or parallel? Are they ordered in sequence or they are parallel to each other?
Parallel.
Parallel to each other. Bravo. So since they are parallel, I need now to find the R equivalent for these two resistance that they are connected in parallel. How they will be? 1 over R equivalent will be 1 over 8 plus 1 over 8. I told you if they have parallel, we have to take the reciprocal of them. So it will be 2 over 8. This is 1 over R equivalent, which is 1 over 4. So the R equivalent here will be 4.
Is equal 4.
This is 4, 8, this 8, and this 8. They are connected in parallel. To find the equivalent, we add the reciprocal of them, we get 4. For this 4 now, what did you have? You will cancel, or you can combine them in one parallel circuit. So you can combine them now in one series, in one resistance as 4 ohm, which we found that the R equivalent here is 4. So this 4 now, you will connect it to this resistance, which is 8. Then you will want now to find the whole R equivalent or the R total. Since now 8 and 4 as connected are connected in series, you will add them. Take 1 minute, think about them. To give you another. Now, do you have any question?
No, teacher.
Right. I will give you now another example. Yeah. If you have now like Now, here I ask you now to find the R equivalent. 2 ohm, 3 ohm, and 6 ohm. You need to find now the R equivalent. So the first step, you must start with the parallel. Which are parallel? 3 and 5 or 2, 3 and 6? Which they are parallel to each other? 2, 3, and 6. Good job. So 2 and 3 and 6, these 3 series now, I want to write them in what equivalent? So since they are in parallel, we remember that to find the R equivalent, you have to say 1 over R equivalent is 1 over R1 plus 1 over R2 plus 1 over R3. Then R1 here is 2, R2 is 3, and R3 is 6. You need now to add them. Just here multiply by 2 by 2, by 3 by 3. So you have it as a 3 plus 2, 3 plus 2 plus 1 over 6. We have it as 1 ohm. So these, since they are connected in parallel, you will combine them in one resistance, which is 1 ohm. So you will draw now, instead of these 3, sorry, so you will now draw a new series instead of these 3 series that they are in parallel with one series, with one resistance, which is 1 ohm, which is the R equivalent. After I replace it now, I have now 3, 5, and 1. How they are connected?
Series.
In series. Bravo. So since they are in series, the R equivalent will be R1 plus R2 plus R3, which is 9 ohm. 3 plus 5 plus 1. Is it clear?
Yes, teacher.
Yes.
Another example now. Now, here, I want you now to find the R equivalent or draw the equivalent circuit. So what you have to do, first, as I told you, you have to search or to look at the parallel circuits. What are the parallel circuits? Oh, the parallel.
The first one, 2 and 2.
Yes, bravo. 2 and 2. Here, the 2 resistors are connected in parallel. So I want now to find the R equivalent for them. 1 over R equivalent will be 1 over 2 plus 1 over 2, which is 2 over 2, or it's mean 1. So for this 2 series, the 2 resistance that they are connected in parallel, I can replace them with 1 series, which is its value now is 1 with 1 resistance, which is its value is 1 ohm. Now let's talk about the second parallel circuit, which is a 3 and 3. I need to find now the equivalent resistance. So here we have it as R equivalent, 1 R equal 1 over R equivalent will be 1 over 3 plus 1 over 3, which will be 2 over 3. This is 1 over R equivalent. So R equivalent
will be 3 ohm.
3 over 2, bravo, or 1.5. So I will replace now. This is new. So this new parallel resistance. Oh, this parallel resistance with a new one, which is its value is 1.5. After that, I look at it now. They are connected in. How they are connected? In parallel or in series?
Series.
Series, bravo. So the R equivalent will be 1 plus 4 plus 1.5 plus 5. You have just here to add them, you get the answer as
11.5
ohm. Since they are in series, I told you that the R equivalent for the series is R1 plus R2 plus R3 and so on. Is it clear?
Yes,
Yes,
teacher.
teacher.
Now, look at this circuit here. I will skip it for. Oh, before talking about it, let's come back here. Now, for this one here, let's imagine now we have an, sorry. Now, we have this series. Let's now connect them with a voltage source. Like this. Let's now imagine that we have these 3 resistance and they are connected with a voltage source of, let's as an example, say it's 20 volts. Now, we found before that the R equivalent, if we draw it here, 8 and 8, they are 4, 4 plus 8, they are 12. So we have it here as 12 volts, and here we have it as 20 volt. Sorry, the R here is in ohms, not in volt. So the R equivalent, we found it before as a 12 ohm, and we assume that, this is assumption, okay? I assume that I connected this series and parallel resistance with a voltage, which is 20 volts. So I have it now as 12 ohm, and the voltage is 20. What is the current here? I want you now to find the I total. So we found the R equivalent here as 12 ohm. What about now the I total? It will be 20 over 12, bravo. I divide and V over R. I get it as 5.3 or 1.6. So this is 1.6 ampere. Now, I want you now to find I1, I2, and I3, I4. This is here we have I1, here we have I2, and here we have I3. and I want you to find V1 and V2 and V3. For this one here, this is a combination. So you cannot say, teacher, since they are in series, so all the current will be the same. No. Here, this is different. Look at me here, what you have to do. We found that the I total is 1.6. So the current that comes from this circuit here will be, and this will pass from the first resistance. But since it didn't, since it is connected here in series, so the I1 will be the same. It will not cut, it will not distribute it. So the I will be the same as 1.6 ampere. But when it reaches this point, what did they found? They found that we have two ways here. Where should I have to go? Should I go up or down? We have to go to the both ways. So that's why I told you that the current on the parallel are distributed. So the 1.6, after they pass from the first resistance, when they reach here, they will divide it into 2 points. It could be 1 and 0.6. They have the summation of 1.6. It could be 1 and 0.6. It could be 0.8 and 0.8. So since we have here 8 ampere, we know the amount of resistance, we know the amount of voltage, we have to find now I2. So to find I2, you have to say it is V2 over R2. I mean 20 over 8, which is, just 1 second.
2.5.
Yeah, I found something wrong here. 8 and 8, it's 2 over 8, it was 4 plus 2 is 12, يعني 20 over 12, must be 1.6. How do we beat 1.5? No, don't divide it. Sorry. Here, since they are divided out there, so we come back here. Now the current is passing through these two and they are distributed. Since they are distributed and we have the same amount of resistance, so that's mean the current will be divided into 0.8 and 0.8. Since they are equal in resistance, so the current will be 0.8 and 0.8. So I2 here will be 0.8 ampere and I3 will be 0.8 ampere. After they connected back and come back to the voltage source, they come with 1.6 ampere. This is here for the current. So I will repeat, it will come, or it will pass from the I1 with 1.6. When it reaches this point, it will be distributed into two paths, 0.8 and 0.8. Then after they connected out, after they connected here, we come back with 1.6 ampere. Now, if you need to find now the current or the voltage at any point, at V1, I mean, to find V1, you have to remember that it is I1 times R1. Where is I1? It is 1.6. Where is R1? It is 8.
8.
So 1.6 times 8 is 12.8. It's approximately 12.8 ampere. If you want to find now V2, how it will be? I2 times R2. I mean 0.8 times 8, which is 6.4. And V3 will be the same, 6.4. Now, next lesson, inshallah, next week, I will tell you how to know what is the voltage across any resistance. For here, as you see, the voltage is the same, 6.4, 6.4. They are the same in V2 and V3, and the miss, I think that I made something wrong here. صراحة يعني لأنه في شيء عندي أنا مش ظابط. I will check it and next week I will repeat it with you.